Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integral inequalities, right? So in this class we'll solve this problem in which we have to show that the integral 0 to 1 e raised to minus x cos 2x dx is less than or equal to e minus 1 over e, right? Where e is the exponential number. So let us start. So viewers, whenever we come across with these kind of problems, what we do, we use this property, right? Say if we have two functions, say f of x and g of x, right? And f of x is greater than or equal to g of x in the interval that is a to b, right? So when f of x is greater than or equal to g of x in the interval a comma b, then the integral of f of x from a to b is also greater than or equal to the integral of g of x from a to b, right? So this property can be used to solve these kind of problems. So here we have to first find out the functions f of x and g of x, right? So what we will do, we'll start with the cosine of 2x, right? Now see, from trigonometry we know that cos 2x is less than or equal to 1 whenever x belongs to the interval 0 to 1, right? So this is the first step to solve this problem. So cosine 2x is less than or equal to 1 when x goes from 0 to 1, right? Now what we will do, we'll multiply this inequality both sides by e raised to minus x, right? So when we multiply e raised to minus x, then we get e raised to minus x cos of 2x, and here we have 1 times e raised to minus x, that is e raised to minus x. So here one thing is very important, that e raised to minus x is always greater than 0 for all x belonging to the set of real numbers, because see, e raised to minus x can be written as 1 over e raised to x, and e raised to x is always greater than 0 for all x belonging to the set of real numbers. So here when we multiply this inequality both sides by e raised to minus x, the direction of the inequality remains the same. So now we can rewrite this inequality as e raised to minus x is greater than or equal to e raised to minus x cos 2x. So now we can compare this inequality with this one, that is f of x is greater than or equal to g of x, where we have the interval a comma b. So here a is 0 and b is 1, right? So f of x is our function e raised to minus x, and g of x is equal to e raised to minus x cos of 2x, right? So now once we have established that f of x is greater than or equal to g of x, then the integral of f of x from a to b should also be greater than or equal to the integral of g of x from a to b, right? So integrating both sides, will get 0 to 1 e raised to minus x dx greater than or equal to the integral 0 to 1 e raised to minus x cos of 2x dx, right? Now let us take this integral as I, right? So now here we can write I, and here we have 0 to 1 e raised to minus x, The integral of e raised to minus x is e raised to minus x, and here we put a negative sign, right? And the limits of integration are from 0 to 1. So now we can write this inequality as I less than or equal to minus, here we have e raised to minus x, and limits are from 0 to 1. So this is minus, taking x is equal to 1, we have e raised to minus 1. Taking x is equal to 0, here we have e raised to 0, right? So this is minus 1 over e, and here e raised to 0 is 1. And we can also write this expression as 1 minus 1 over e, right? So we have I less than or equal to e minus 1 over e, right? And this is the required inequality. So here our I is this integral, so we can also write it as 0 to 1 e raised to minus x cos of 2x dx is less than or equal to e minus 1 over e, right? So viewers, this is how by the application of this property we can solve these kind of problems.